We're almost done. Now, this is what we call a square root function. Did you guys do this last year? Is this new to you? Hands up if this is new to you. Okay, thank you. All right. As you can see, all we're doing is we're just squaring the x value. So, for example, if I have a 9, I square root the 9. What does 9 become? 3. If I square root of 16, Jesse, square root of 16. 4. Okay. What's another square number in here?
9.
4 becomes 2. Square root of 0. 0. You can see it's not very neat. You're going to have in between these whole number nice values, decimals, but they're still there. Just because a square root of something is a decimal, it doesn't mean it's not nice to plot. They're still following that pattern. Can I continue on this side?
No.
No. Okay. Because you can't have a
Negative.
square root of a negative. This side does not exist for this square root anyway. Okay.
And there's also roots of plus or minus.
Yes. We'll get to that. Okay. Okay. So, as Gabe has alluded to, I can put a negative of square roots of positive numbers. Not quite. Not left. If I put a negative in front of this, so I'm putting a negative in front of these values. Where does it go? Left or does it go right?
Left.
Where else can it go? Down. Thank you, Emily. Think about it. Let's punch this in. If I have, let's pick on 4. X equals 4. Y equals negative square root of 4. Can I have, even though there's a negative here, can I still have an answer? I can. This is still positive. Root 4 is 2, but we whacked on a negative at the end. So 4 goes down to negative 2 now. And it will follow, all those values will follow this way. What I'm trying to say, when you have a negative outside the square root, it flips down. Okay. Question.
That one is the same as the negative.
Yeah. It's just a mirror. Boys, this is important. Important. Okay. What other variations can we have now in this one here? We've done these. Can I graph that?
Yeah.
Yes. Why?
X equals negative something.
Good. I was going to give a line, but I didn't say it. If x equals negative 1, what happens inside here? We have a square root of a positive. It can happen. So if I go negative here, for this one only, this is negative 1, but a negative 1 links up with a 1. So negative 1 is 1 up here. Let's do it again. X equals negative 4. X equals negative 4. What's my final answer? 2. The square root of a negative 4. We're safe because the two negatives make a positive. It's a 2. So negative 4, 1, if I go here, sorry, I went too far there. That's 1, 2. Negative 4 is at 2. We're going that way. Okay. Get you in your head, if there's a negative
So,
inside, it flips where?
other way,
What's the other way?
left way.
The left way. What's the mathematical way of saying flips on the left way?
Left.
Not quite.
Oh, okay.
Reflected on the y-axis. Okay? Think about it. So when you're doing your dilation explanations later on, here, if anything goes from here to here, it's flipping, it's flipping along the y. It's reflecting along the y. Anything like this graph here, if it's up here, if it's mirrored, you're looking at yourself down in the mirror, like on a lake, you're looking down, it's reflecting on the
Exactly.
x-axis. X is the middle. Shh. Last question. What do I need to do to get a square root function down here? What do I need to do to this to get it down here? This one. A negative on the outside. Two negatives, a double negative, flips this down and across into this quadrant. Look for those lines, because if you don't know what you're looking for and your calculations are there, you don't have a guide of what you're moving towards. Okay?
So for every type of graph, whenever the coefficient of x is a negative, it flips.
Any untouched square root function always goes that way. That's normal.
Dilation on it.
You can do, yes, there are dilations on them, and we're going to do one with a dilation. I don't think you're going to have to explain dilations, but if there is, I'll explicitly go through it. Okay. I won't leave you stranded.
Do we have 2 exams?
2 exams.
A critic.
Oh, I think it's just, I don't know. I didn't teach methods last year. I think it's just the one. I'll have to say that. Okay. Sorry, this is taking longer than I thought. Okay, lastly, we have something in our square root functions is an endpoint. Notice here, our normal square root function has an endpoint at 0, 0. Okay, but to find any endpoint, it's actually in relation to these two numbers here. Okay, so what's the number for a square root in this question? What can't it go beyond for the x values? What don't we want for x? We don't want 2. So it starts at 2. Okay. This one started at 0, 0, but we're lifting up our original square root function. So if we lift up, this is a root. When you're doing your weeding, you pick up the roots. If you do weeding at home, if your parents do the weeding at home, you lift it up, and it's 1 at level 1 now, not on the ground. It's been rooted, plucked out of the ground. Okay, 2, 1. So that's your starting. Okay, 2 things we're looking for: x-intercept and y equals 0. So if we have this, we are going to have an answer. Okay. Just quickly run through this. I'm going to change my text there. +1, -1. Negative and a negative. There's a 1/3 positive. That just went down, and then negatives cancel themselves out. Square root, opposite of square root, Maya. What do I do on the other side? We square them. Okay, so we have a 1 on 9 equals x minus 2. Last step is a 2 and 1/9. That's our x-intercept. Okay, so when I go over here, we're looking for 2, 1, 2, 1. Okay, now look carefully. From this endpoint, which is actually the starting point. So, okay, I know it's confusing. At the end of this graph, which way is this going to travel? Is it going to go right? Is it going to go left? Is it going to go right down? Is it going to go left down?
Left down.
It's not left down. Okay. Remember, our negative is outside. There is no negative in front of the x.
Oh my.
Okay, so we're going to go. We're still going to go right, but we're going to go down. So that's the normal, but we're going to go down this way. But look at the work that you did. 2 and 1/9. 2 and 1/9 is right there. It's actually telling you to go down anyway.
And 1/9 pretty close to 2.
Correct. My bad. There you go. 2 and 1/9 goes down that way. You cannot go out here and come back to here. That's just, you're just lost if you're doing that. Okay? So that is going to go down like that.
How many points do we need a graph like on this problem?
Good question. I will answer that in a second once I finish this. Okay, I'll come back. X-intercept, y-intercept, x equals 0. When I do this equation here, Nathan, what's going to happen when I do this equation here? Looking at the graph here, going to be undefined. Thank you, Nathan. Paying attention. Let's do the working out. X equals 0, negative 3 on 0 minus 2 plus 1. Straight away, square root of the negative 2. Undefined, done. Stop. Don't do anything else. And we can see it on the graph. It can't turn back onto the y-axis. Okay. This is I would say, Zach asked a very good question. How many points do we need to show? Now, I would say, number 1, for a square root function, you must have an endpoint all the time and another point. That other point might be an x-intercept. You've got two enough already. I just want 2. But if your endpoint starts here and doesn't hit any x-intercepts, I would substitute just another point so you know the trajectory of the. Okay. At least 2. Any questions? Okay. I'm going to give you out Friday's notes, today's notes, and practice sack. I will send out the solutions for the practice sack maybe tomorrow. Okay.